Okay, so we have notes 2.6, which is an intro to graphing linear equations with a calculator. So first thing we're going to do is talk about y-intercept, which is the number with x at time 0. Okay, that's the definition. Here's a table. If we make a table like this, our y-intercept is when x is at 4. So here's the x. I'm sorry, when the x is at 0 and the y is at 4. So anytime it's at time 0 for x. For the equation, right, if I have two of these are random numbers that were generated in class, this 25 that's by itself with no variable, that is our y-intercept. Same with this negative 99. When I graph, right, if I make a basic linear graph, right, the y-intercept is where it passes through at the y-axis. Next up is slope, which is our common difference. It's just a fancy way of saying common difference, because we use the words common difference for when we're talking about arithmetic. Now that we're talking about linear, we want to use slope. But again, they mean the same thing. And the common difference will always be in front of our x, our slope will always be in front of our x, just like how our common difference was always in front of our x. So here's a table. For our table, you find the slope by figuring out what math are you doing down the table. And remember, if it's linear, we're only adding or subtracting. So if you think you're supposed to multiply or divide, something's gone horribly wrong, because those are for exponentials. In the equations, again, it's that number in front of the x, including the sign. So this plus 6 and this minus 16. In a graph, the slope is how we move. So going to the right 1, up 2, or what you will see soon is going to the right 3, up 1. And then slope-intercept form are linear equations starting at time 0. So some examples of a linear equation starting at time 0. So let's say we have y equals 5,000x plus 98. Well, the y-intercept is that 98, that number that's by itself. The slope is the 5,000, which is the number in front of our x, or what would be our common difference, the math we would do down our table. Number 2, y equals negative 1 plus 56,000x. Well, y-intercept is the negative 1 without the variable. The slope is the 56,000, right? We would add 56,000 every time we take a step down the table. Next up, we have y equals 19 minus 27x. The y-intercept is that 19, that number that's by itself. And then that negative 27 is our common difference, aka our slope, because it's attached with the x. The x tells me how many times I'm going to be subtracting that 27. All right. Now we have to use the explicit equation to answer the following questions. Oh my goodness, I cannot read today. So we have y equals 3 plus 2x. Well, blank is the starting value. Well, 3 is the starting value. And blank is being added repeatedly, where the 2 is being added repeatedly. How do we know? Because it's got the x attached to it. The x is telling us, hey, that 2 is what we add as we go down that table. Rewrite it with the x first. So we're going to have y equals 2x plus 3. This 2x stays positive, right? This 3 stays positive, okay? Now, even though we know the starting number and the common difference, let's plug the numbers from the table into the equation. And the equation, again, is that y equals 2x plus 3 into our calculator, and then plot the points. So here, we have our table. Okay, see how it still says 2 blank plus 3? We're replacing the x. So here we're going to replace x with 0. So in my calculator, 2 times 0 plus 3, well, 2 times 0 is 0. 0 plus 3 is 3. Or if you just know from all the practice we've been doing that this 3 is the y-intercept, then there you go. Then you could try 2 times 1 plus 3. 2 times 1 is 2. 2 plus 3 is 5. Then we do the 2. 2 times 2 is 4. 4 plus 3 is 7. Now the 3. 2 times 3 is 6. 6 plus 3 is 9. Again, you can use your calculator for all of this. Plug in that 4. 2 times 4 is 8. 8 plus 8 plus 3 is 11. Now, if I wanted to go backwards, right, I would do the same thing. I would take y equals 2 times negative 1, because that's what's over here in the x, and then plus 3. And I plug that into my calculator and I'll get a 1. Same thing, 2 times negative 2 plus 3 would give me a negative 1. Negative 1. Okay? So again, if you know how to handle the equation without using the calculator, that's fine. If you feel more comfortable with the calculator to check your math, that's cool too. Okay, so let's start with the y-intercept. So our y-intercept is 0, 3. Okay. And then our next point after the y-intercept is 1, 5. So 1, 5 is right here. Let's look at this movement. We got to go from the red dot to the black dot. We go to the right 1, up 2. Let's see if that movement works again. Go to the right 1, up 2, and plot that dot. So this dot's new numbers are 2 and 7. Let's see if that's the next one. Oh my gosh, it sure is. Let's do that movement again. Right 1 up 2. So this number of this point is 3 and 9. Let's see if that's the next one. Oh my gosh, it is. Now we can't do 4 and 11 because our table only goes up to 10. Let's go backwards. So we want to get to negative 1, 1. So negative 1, 1 is right here. So how do we get from the red dot down to this like white dot surrounded in red? Well, we go left 1, down 2. You do the opposite movement. And we would do that again to get negative 2, 1. All right? If you're like, what just happened? Hey, use that table. Graph the points using the table. We have been making linear equation tables for 9 weeks. So if you want to be using the table rather than the movements, that's fine. D says we know the starting number is 3, which is also known as the y-intercept. So we're going to circle, since we don't have highlighters, we're going to circle where the y-intercept is in the equation. Well, in the equation, here's the 3 for the y-intercept. Then in the table, it's right here. In our graph, it's on the y-axis. So those are how you find y-intercepts from tables, graphs, and equations. Now, we know the common difference, aka the slope, is 2. Explain where you see them in each of the following. So in an equation, that common difference 2 is right here. It's in front of our x. So I'm going to write that, right? In the equation, it's in front of x. In the table, well, where do we see the 2 in our table? Well, if you think about this, as we go down our table, every time we go down, we are adding by 2. So it's the math of our table. And remember, they're linear, so that's either going to be adding or subtracting. No multiplying, no dividing. Last thing is it's asking where can you find the slope 2 in the graph. This is a doozy. This messes up a lot of people. But let's look at this. Every time we're going to the left, or going to the right, we go right 1 and then up 2. So for our graph, we're going up 2, right 1. Now I've asked a couple of classes, and so far everybody seems to know this, but if I want to turn, this is like a side note, this is kind of help prepare you for Monday, but how do we turn the 2 into a fraction? Well, anytime you have a nice number, any nice number, 2, -2, 3, -4,000, anytime you want to turn a nice number like that into a fraction, you put it over 1. Now this 2 is positive, and that's where we get the up 2. This 1 is positive. That's where we get the right 1. Okay? So keep that in mind for Fun Day Monday. All right, now if we wanted to graph the equation y equals 2x plus 3 without a table, well, first we would plot the y-intercept 3, right? The y-intercept 3 on the y-axis. Y-intercepts always go on the y-axis. Step 2, we would use slope to go up 2. I'm being lazy here. We're going up 2, right 1. Okay, so that's how you use the straight up slope-intercept equation. Start with that y-intercept, then use your slope. So I want you guys to try the second page, and then we'll go through it together. So here we go. We have y equals 7 minus 3x. 7 is our starting value. -3 is what we do that on the table, or what's being added repeatedly. Now you can write plus -3. You can do that. But a positive and a negative turned into just a -3. Okay? So it doesn't matter. It still means the same thing. So don't let that confuse you, because it does seem to confuse people. When we rewrite it, we write -3x. The sign follows that 3, and so does the x. I had a lot of people have this be negative. No, no, no. This 7 was positive. It's going to stay positive. All right? Then we filled out the table, and if you used a calculator, great. If you used how we've been doing it since arithmetic days, then that's fine too. Here's our graph. In the equation, the 7 that's by itself is our slope-intercept. 0, 7 in the table is our, 7 is our y-intercept. 0, 7 in the table is also our y-intercept. So y-intercept, y-intercept, and on our graph, y-intercept. Good gravy. That's all I really wanted you to do. If you filled out the rest of it, that's fantastic. But really, I just wanted you to get through to those first few sections. We did not go through the back, 3, 4, 5. We did not do that, so don't worry about it. What we did say is that you have to do your homework, 2.6. It's 4 problems. Okay, and then there's some extra credit too to help you start quarter 2 on a good note. All right, everyone, that's it for the day. Have a good one.